Assalamualaikum warahmatullahi ta'ala wabarakatuh. This will be a real quick lecture video for the last topic in our dynamics, which is work energy for rigid body. Okay, so the equation that we'll use here is the same one that I have shown you for work energy during a particle. Okay, so we have U12 equal to delta Vg 12 plus delta Ve12 plus delta T12. Okay, so we have U12 is the work done, delta Vg is the change in gravitational potential energy, delta Ve change in elastic potential energy, and the last one is change in kinetic energy. Okay, so we will see in this chapter what is the difference between the calculation for particle and for rigid body. Okay, so we start by the first one, U12. Okay, so here we have U12. In particle, we have this first three, which is work done by a constant force, which is the equation is F times S. We'll use the same equation. Second one is work done by a constant force through cable. Okay, so U12 equal to P A minus B. Okay, A and B is the length of the cable. You have to refer back to the first to the work energy for the particle. Okay, and the last one is, and the third one is work done by a constant friction force. Okay, so the equation is negative F times S. It is always negative as the friction force will opposite direction of the movement. Okay, and the adding part, which is the work done by a couple. So the equation is U12 equal to M d theta. M is the couple. Okay, either given directly as a couple or given as a force, and you have to times the distance to get the couple. D theta is the change in the angle in terms of radian. So here I put the conversion from 1 degree to radian. So 1 times pi over 180 in radian. Okay, so quick review, flashback. U12 for the constant force, we have P times S. So the P is the constant force. So you need to remember that this force must always constant in terms of magnitude and also direction. None of that cannot change. Okay, and you just times the P times the SS is the distance in the same direction of the P. Okay, the second part is U12 from the cable. So you need to, the P is the constant force, the cable A and B is the length of cable. We need to know the difference in the length of cable. So you just put the equation, and then the last one is, the third one is friction. Okay, so let's see for the couple. Okay, so U12 from the couple, there is the difference between U12 from the this one constant force and the couple. Okay, either given as a couple itself, M equal to 10 Newton meter second, so you directly can say that it is a moment here. So the U12 equal to M times d theta. So in this case we have M 10 given theta. You have to know what is the angle involved in this one. So the position 1 and position 2, so you have the angle is here is 90 degrees. So you put 90 degree, convert into radian, so you got the answer. Okay, so here is the second method. It is not given in terms of moment, couple, it is given in terms of force. Okay, so you have to first calculate what is the moment created by this force, which is F times D. F is this force, D is the 90 degree distance to the pivot point, which is 0.5. So 10 times 0.5, you have the same angle. Okay, so from here you can clearly see the difference between the work done by a constant force and the couple. Okay, here let me show you that. Okay, this is work done. If we have this condition, we will use work done by a constant force because the force is constant in terms of magnitude and also the direction. Both is constant here. Magnitude is constant, direction is also constant. But for the couple, you see only the magnitude which is constant, but the direction is not constant. Okay, but it is constant relative to the road, which is in this case, for example, we have 90 degree to the road. Here also we have 90 degree to the road. So this is the big difference between work done by a constant force or work done by a couple. And also you have to consider the direction. If moment is clockwise but the movement is counterclockwise, you have to put negative, which is opposite direction of the couple given, same as this one. Okay, so this is the first one. Okay, so before we go further, I would like to show these 4 examples, okay, to differentiate between work done by a constant force, by a cable, by a moment, and so on. Okay, we have this 4 position, 1, 2, 3, 4. Okay, this one, you see that the force is constant in terms of magnitude and also the direction. So we can consider this one is work done by a constant force. Okay, so work done by a constant force, which is the equation is by P times S. Okay, in this case our S will be this one. S is 1 meter. Okay, the distance in the same direction as the P. The second one, okay, we have a cable and a constant force in terms of magnitude and also the direction, but through cable. So this one, the second one, we will use work done by a cable. So U12 equal to P times A minus B. So this one, P A minus B. Okay, so what is A, what is B? A is the length of the cable at position 1, so this is A. So this is the B. So you put the information there, you will have the result. Okay, so the third one, okay, you have also the cable. You cannot directly say if you have the cable, it is constant force through cable. No, you have to look at what is at the end of the cable. In this case, here the question directly said it is a constant force, but here it is not a constant force at the end of the cable. Okay, we have a mass 3 kg here. Of course, if it is a static, the force in this cable will be constant. The first position and second position will be constant if it is a static calculation, but it is not static. Okay, it is a dynamic calculation. Okay, moving component, so we cannot sure that the force inside that cable is constant. So in this case, we have 3 kg here. So in this particular figure, U12 in terms of constant force will be 0. Constant force through cable also will be 0. Friction, if not stated, will be 0. There's no couple, but you have 3 kg. So this 3 kg you have to put inside mg delta H. Okay, so here you have to put mg delta H. Okay, which is delta Vg. Okay, delta Vg 12. Delta Vg12. Okay, delta Vg12 equal to mg delta H. Okay, so in this case, the mg delta H we have to calculate for both. The first one for this one, and the second is for this one. You have to calculate 2 times. First one, mg delta H for the road. So the delta H in this case, which is at the center of gravity. So from here to here. So this is delta H1. And the delta H for this one. So if it's moving from here to here, so this is delta H, delta H2. So you have to add these two, you get the answer. Okay, and the last one here is, at the end of this cable, you have let's say a motor that gives you a constant torque of 20 Newton meter. So this one you have to consider work done by a couple, because you have a couple here. So you have to use equation. This is U12 equal to, which is P d theta. Okay, the P is 20 the Newton is 20, torque is 20, and then the angle is moving from here to here, so it is 90 degree. So 90 convert to radian, 1/80. So you have the answer 31.4 Newton meter. Okay, moving this direction and it is moving same direction, so this one will be positive. So I want you to really differentiate between these four position: constant force through cable. There's no constant, no U12. This is delta VG12 because there is a mass here, and this one because there is a given a couple here. Okay, torque 20 Newton meter, so you have to consider it as work done by a couple.